Now, when we talk about measuring energy, we immediately talk about our I/O system. And if you take a look around here, these are all terminals who measure different signals, different currents, voltages, or analog signals, whatever you name it. But this is only 1/3 of the total program. So I need Fabian to help me. Good morning, Fabian.
Good morning, Roland.
Out of this portfolio, there's a huge range of different terminals for power measurement.
Correct.
So why do we have even a variation for power measurement?
Good question. So the problem is, or the good thing with us is, it depends on the customer, what he's needing. Maybe some customers only want to do energy management. Management purposes usually are rather slow. So 10-second update time is totally enough for them. So this is our management group. We have a second group, the measurement group. This is for our standard machinery customers. They usually want to measure way faster and maybe even optimize regulations on that. So then they need milliseconds, and then they can optimize their processes with it. And some of our customers even want to go faster than that. They need microsecond precision in the timing and really want to see the AC current and voltage going up and down and see the instantaneous values, and they then go for our monitoring group, use our oversampling technology, and then they really see every single detail of voltage and current and energy.
So during this week, we talk about price and cost optimized products. This is basically really an answer because you take exact the function, the feature, according to your requirements, either very sophisticated in microseconds, standard millisecond, or all the way up to just a few seconds, and write one terminal according to the demand.
Exactly.
So every machine user basically can do that. And I think you told me up front, every machine builder even should do this as well to measure the energy.
A very good point. Energy is getting more and more cost intensive. Everything which is costly, you want to optimize. And when you want to start with optimizing a process or an energy application, then you need to measure it first. And that is something really everyone can do. Doesn't matter if it's a machine or a house or a plant, whatever consumes energy should be optimized. And so I hope in every machine we sell, in the final end, we should have an energy measuring terminal.
Now, energy, power is, from a physical point of view, current by voltage. Very simple. I think we learned this in the physics already at school. Now, I looked it up, and you even have some terminals where we, of course, measure current, but we don't measure voltage anymore. So how can I get power with that?
Good question. So
it's not an April 1st surprise. It's a real question.
Yeah, well, true. So this is called distributed power measurement system. So why is it distributed? Because we separate the voltage measurement from the current measurement. So obviously, as you said, we need the voltage information. So we do that once in the system, and then we can transfer this digital information of the voltage to a different terminal. But now, take care, if you have two different measurements and you want to multiply them with each other, you need to be sure that the moment in time is the same one when they were taken. Because if you multiply two different time domains, then it doesn't work. So, since we're using EtherCAT, we have our distributed clock system inside EtherCAT, and that takes care about that. So EtherCAT synchronizes all the devices, and then we can be sure that the measurements, even though they are separated, were taken at the same time, and then we can multiply the digital U information, voltage, with the physically measured current and get our voltage, our power, energy, and harmonics, even though the single terminal don't have any voltage information.
So speed matters. So EtherCAT performance is also helpful for this because with the distributed clock system, it's easy to do this. Now, this is one thing, the voltage. Other thing is the current. Now, current can differentiate from a few milliamp to hundreds and thousands of amps. And I think we also have a special program of components to connect the current into the terminals.
Exactly. So our current measurement abilities inside the terminal going from 1 amp to 5 amp to 10 amps in the maximum, but 10 amps is way too less for most applications. So you need to transfer big currents into small currents, and that is a current transformer. And obviously, we also want to serve our customers with more or less everything they need for an energy application, and then they need current transformers. They get them from us from 1 amp starting up to 5,000 amps, also in different accuracy classes. Maybe class 3 is enough, but maybe you want to be very precise and go for 0.5. Or maybe you have an old application you want to retrofit, then you need split core devices, because the primary conductor should not be opened again, so the transformer needs to be opened.
Yeah.
No problem, we have them in 2 different versions, in big and small. And for new applications, you should use probably ring-type transformers because they are a little bit cheaper, or you get more acquisition with less money, and for new application it doesn't matter. So then I would always emphasize to go for a ring type, and that's all we can offer. So it's a one-stop market, hopefully,
yeah.
for our customers.
So we don't sell the energy, but everything around to measure it.
Excellent.
Now, thanks for the first insight.